Hey everybody, Adam Walmsley here from Autodesk. Today's webinar is going to focus on Dynamo for Civil3D. Some of you might know that Dynamo has been around for some time now inside of Revit, and just this year in Civil3D 2020, Dynamo has been made available, it's pretty exciting. So I've been a Dynamo user for a few years now in the Revit side of things when I was working in a design consultancy. So now seeing it inside of Civil3D, it's pretty exciting for me personally. So let's get into it. So to access Dynamo, up on the Manage tab here of Civil3D, over on the right, you can select Dynamo. We'll start a new script. So what is Dynamo? Dynamo is a visual programming tool that works with both Revit and Civil3D, as I've mentioned. Today we're focusing on Civil3D and some of the basic processes that you can start to look at leveraging through the tool. It sort of extends the power of AutoCAD and Civil3D by giving the user access to the API in a visual way, which is more accessible than being able to read or write code. I'm not a coder. I wish I was. So Dynamo is something that I can pick up and run with pretty easily, and I hope you can too. So scripts, they're created by linking a series of nodes together. We'll get into that shortly. And each node performs a specific task, and the result of each node is a new list of information. List management is pretty important and fundamental when using Dynamo, and there's some resources that I'll share at the end for you to learn more on how that works. The data flows from the left-hand side to the right-hand side of the canvas here, and as I will go to show you, it can be a pretty fun way of working, creating new geometries and processing data in a visual type of way. If you are a programmer, you can certainly create your own custom content using a series of Python scripting, or you can use design script inside of a code block, and I'll talk a little bit more about that as I go on through today's session. But if you're like me, I just stick to the plain old nodes inside of Dynamo. It makes it much easier for me. There is a very active Dynamo community who they create and they share their own custom nodes. So getting into now a little bit of the UI, you can actually search for publicly listed packages up here, and these guys that have developed their packages, they tend to develop things that are very specific and solve very specific problems. You can see I've got a couple of add-ons down the bottom here, and they're really useful to help sort of perform some tasks that aren't readily available in the out-of-the-box library of Dynamo nodes. So Dynamo can be used in a range of applications during your day-to-day. I think it's a great tool that can sit next to you as you're working in something like Civil3D and use it for one-off type processes, or you can certainly write scripts and save them to your file server and share them amongst your team. And you can even start to utilize the Dynamo player up here in the top corner to sort of enable your users to just click and run a script to perform a very specific process without having to come in here and create their own series of custom nodes. So Dynamo can help automate repetitive tasks. It can be used to model really complex geometries. It can run multiple calculations at once, and it can apply the results of those calculations to elements inside of Civil3D. You can also use it to start to audit models and do performance checks. And something that's pretty important as well is that you can actually export data out to Excel, which can be used down the line in other applications across your business. So that's a bit of an introduction to what Dynamo is. So on the left here, you can see that these are the nodes that are available. So depending on what you're looking to do, you can browse through this list to find the information you need. You can use the search functionality, or the way I like to work is I like to right click in the canvas and do a search myself. So let's say point by coordinates, it brings up the node there. You also have the ability, as I said, to use design script to code. So someone could say point.byCoordinates, and that is the same node as the same output as a node, but in a code block or a design script format. There's some different settings that you can utilize when you're in Dynamo, depending on how complex your scripts get. You can play with the scaling of the geometry. Most times you can just leave it on medium. You can manage your custom nodes. Users have the ability to create your own custom nodes, so managing that is done in here. And you can also have, play with the background settings and things like that, but we won't focus too much on that today. So what I'm going to do is get into Dynamo and sort of start to show you how we can use it for some simple stuff. So let's go. So I've heard a couple of people say to me that you can do things in AutoCAD or Civil3D that you can do in Dynamo just as fast, and that's certainly true. But then Dynamo does leverage. There is extra power inside of Dynamo that lets you do things quicker than you could manually do. So what I'm going to do is I'm just going to create a pretty basic polyline here, and I'm going to show you how you can start to use inside of Dynamo something similar to the measure command or the divide command inside of AutoCAD. So I've got a basic polyline. You can also work with 3D polylines, but at the moment I think in Dynamo for Civil3D you can't interact with arc geometry. That is coming. So what we're going to do is we're going to start by bringing some of this geometry, bring the AutoCAD geometry into the Dynamo world. So we're just going to type in this node here called select object. Now I'm going to hit select, click that geometry. The next node is going to be called object.geometry. And you can see if you hover over here, it's going to tell you what it does. So get Dynamo representation of this object. Now you can see that the input of this node is object, the output of this node is object. So those two bits of information will flow together with the use of a wire. So now you can see that in the canvas here in the background preview, I have got that geometry in here, which is that polyline. So let's divide this curve up. So let's go curve dot point at equals segment length. Okay. So what this is going to do, it's going to divide our curve up into a series of equal lengths. Now by default it's put 10 here. We can add a number to our liking. So by double clicking the canvas you get a code block. We can change this to 100 and you need to put a semicolon at the end there to close off that. So here, and I'm running this on automatic. You have the ability to run on manual, which means every time you put some nodes together you need to hit the rerun button to see the updates. But for what we're doing today, I'm going to keep it on automatic just because we're doing some pretty light stuff, so it's not going to take up too much processing power. So as you can see, changing these values here updates those points on the screen. Now you can also use something like a number slider to do this. So if we have a minimum value of 0, maximum value of 1 and a step of 1, we can connect that to the divisions, and as I slide this along you can see those points increasing and decreasing. I'm going to stick with the code block today. So this node here is, I'll just create a group just for my own purpose, and we'll call this one divide curve equally, just so I know. It's good practice to get in the habit of grouping your curves. When scripts get large, it can be hard to keep track of what is actually happening. So that's a divide command inside of AutoCAD, but done inside of Dynamo. Now I'm going to extend some functionality and sort of really start to leverage the power of Dynamo, but for now we'll just keep going with some other types of processes here. So the next thing I'm going to do is I'm going to look at replicating the measure command. Now I'm looking for the curve.points at Segment length, it's not seems to be in the list. Sometimes there is some limited ability when you search like this, so I'm probably going to have to jump over here to the library and find this myself. So curves, we are looking for curve. There we go. Points at segment length from a given point. That's what we're after. Okay. So now what we can do is we can assign some geometry to that curve. The point we want to use is a start point. So we're going to get the start point of this curve here, feed that into there. And again, we want our segment length to be, let's say, 50. So what it's gone and done is it's putting a point at 50 along the curve. And just to let you know, there's another node here called curve length. We can check the length of the geometry that we've created here. So you can see it's 223. If we select that in Civil3D, you can see that the curve length is 223. So this node is now doing measuring from one end of the curve. Okay, so that's sort of similar to your measure command inside of AutoCAD or Civil3D. Now another one, again extending that functionality a little bit further, you can start to specify specific lengths along a curve. So curve.point at segment length. Okay. Now we can connect this geometry here, and let's say we want a segment length of 25. So from the start of the curve, it's going to place a point at 25 units. In this case, let's call it meters along that curve. Now where it gets interesting is you can start to add multiple values to this, and it'll create points at different places. So I'm sure there's better ways to do this, but let's just start by saying we want 20, we want 50, we want 80, and then we want 150. Okay, I'm going to create a list of those values, and this is where list management comes into it. I'll provide some information at the end, but the Dynamo Primer is a great source of information to understand what's going on here. But basically you can see it's created a list of values at 20, 50, 80, and 150. Now I'm going to feed that into our segment length, and you can see in the background here now that we've got a point at 20, a point at 50, a point at 80, and a point at 150. We can change this around, make this a smaller value, 10, and instantly you can see how these points are changing. So that is a little bit of extended functionality from your measure and divide. Gives you a little bit more control over what you can do. Dividing up a curve into different points. So let's just group this one, and I'll call this specific lengths along curve. So that's all well and good. Pretty basic stuff there. It's not too mind-blowing, but what we can then start to do is we can create geometry in Civil3D here based on this curve, right? So to keep it quite simple, let's create a circle. We're going to place the circle by the center point, and we also need to specify a radius. So let's just stick with 10 here. Now, also worth mentioning that you can apply inputs of strings, which is typically your text, and you can also apply numbers as well. So using a code block sort of shortcuts those two nodes, and you can just use a value like 10 here. If you are placing text, you need to if you are using a string, you do need to put it in inverted commas like that. It's just something worth knowing. Okay, so let's see. Go back to our curve here. We've got our divisions. and dividing it up equally in 10 spaces. And now what we're going to do is we're going to place a circle along on that geometry with a radius of 5 at that point. Similar, we can take this out here, we can do this same process there, and similarly we can take that curve down to here and take that point to there, and you're getting the same result. Let's just stick with this process for now, the divide equally. Okay, so you can start to see that dividing up a curve, placing some geometry on that curve. Now what we can do is we can write that information back into the AutoCAD environment. So there's a node here called object.byGeometry. Now this is the node. If we hover over it, it's going to tell us creates AutoCAD object from Dynamo geometry. So we've started this process by taking AutoCAD geometry into the Dynamo interface. Now we are writing the results back into the AutoCAD environment. So the geometry in this case is going to be a circle. The layer, so using a string, we can create our own layer. So we can call this circle layer. And as you can see, I've put it in inverted commas. And the block, so what we need to do with that is we're going to place it in model space. This is a bit of background information that I learned when I first started using Dynamo for Civil3D, but you need to specify the current document and where you want to place it. So you can also do this in paper space, but we're working in model space for this example. Now I click there, you can see that we've placed those circles back here in AutoCAD, and it's put it on its own layer, it's created its own layer. So you can start to see that you can use Dynamo even to create a library of layers in your project to suit your in-house standards, things like that. Now, what is really powerful, and this is where I think Dynamo sort of wins out over doing these types of divide or measure commands inside AutoCAD, is that we're running this on automatic. If I grab this polyline and I extend that geometry, it automatically updates, which I think is pretty powerful. So it's running that whole process instantly as soon as the geometry changes, and we're getting the same output. I think that's where you start to see some improvements or some efficiencies by using something like Dynamo. So similarly, okay, let's just test this out. We can take the same curve geometry, measuring from one end, and we can place that point there. Now if we divide this up by 10, we're going to get a lot of geometry in there. And again, this is updating really fast, which I think is great. So for now, we'll just go back to our divide geometry. All right, so now what we can then look at doing is labeling some of this information. Okay, so let's say we want to number all of this stuff, and you can use Dynamo to actually place some text into your model. So here you can see that we can start to create text. So the final output here is to put some text into this workspace, and let's show you how that can be done. So we're going to count these numbers sequentially. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Way to do that, we can first find out, we can use a node called list.count. Now what that's going to do, it's just going to quite simply tell us that there's 10 items in this list. Okay, we need to use that because we're going to create a range of numbers. So we want to start a range from 1 through to this number 10, and then we're going to place the text in the model that way. Okay, so next is to create a range. So we want our start value here to be 1, we want the end to be 10, and we want our step to be 1. So we can see now we have a range of numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just to show you, if we change the step to 2, you end up with a different list of values like that. But we're interested in keeping that step of 1. So we've got our range. Now we need to start looking at plugging this information into the text create node. So the text, our insertion point, so it's asking us to define where we want the text to be inserted. To keep it simple, I'm going to place the text in the center line, in the center of this circle. So you can see that, actually, sorry, that's not right. We're going to put it at this point here, which is the defined division of this curve. So we take this node here and put that there. We can specify text height. So let's let's go 5mm high text. We want to define a rotation. We can leave that blank. We want to put a layer, so we can call this text layer. And that's, what have I done? Okay. So height 5, the layer is going to be called text. The rotation, we're not going to worry about that for now. And again, it's asking for our block, so we can take our model space block over here. And lastly, we're going to place our text into here. So if we just put that in there, we've got an error. Okay, what's this error? All right, so if you hover your mouse over here, you can see the text is asking for a string input, whereas this is a number. So that's not going to work. So what we need to do is convert that from a string to, string from object. That's it. So we've got an object in here, and the output of that is going to be the same thing, but it's in a string format, which lets us place that text in there as such. So that's it. You can see how now, if I move this around, it's going to follow. If I change this division all the way back at the start, it's going to quickly place that text back in the model quite nicely. So there's some of the extended functionality that you can start to get from utilizing Dynamo. And this type of process, it's scalable. So you could save this on a system and give it to your CAD users and say, hey guys, you can use the measure and divide command inside of Civil3D, or you could use something like Dynamo, and it's a little bit more dynamic and it follows your geometry as it changes. You can also then start to instead of placing a circle, for example, you could then start to actually place a block reference, right? So this node here, block reference.create, instead of a circle, you can create a block if you have a block definition defined. So the next workflow I'm going to show you is the end result is actually creating a block in there. So what we're going to do is, let's just start a new script. We won't need to save that one. And we need to set this up a little bit. So what I'm going to do is just delete all this stuff. So the first time I started to use Dynamo, Dynamo and Civil3D, I thought, what can I do here to sort of speed up my workflow? And one thing that I came up with is using Dynamo to place block instances based on an Excel spreadsheet. So what I'm going to do here is just cheat a little bit and create some points in the canvas. Now, this could be some survey information that you've received from a surveyor on the location of trees. In this instance, it could be a survey file of power poles. I've got a block definition in here called power pole, so that's what we're going to be using today. So what I'm going to do is just cheat a little bit here, do a quick data extraction to generate a Excel spreadsheet. Create new data extraction. Let's just call it AW. Next. We are interested in circles only, and we are only interested in the center X, Y, and Z. Hit next. We can output that to a document there. Finish. Okay. Jump over to my documents. I have that Excel spreadsheet here. Let's just check it out quickly. So you can see there's our data. What I might do is just clean this up quickly, get rid of this. So now we have X, Y, Z. You can see that this is all 0. We'll leave that for now, but you can certainly have values in the different Z values and use it that way. So let's close that, delete all these circles, and jump back into Dynamo. So what we want to do is we want to import some Excel information. First and foremost, we need to get Excel data into here, and it's asking us that we need to find that file. So let's go to File Path. This is going to let us select the Excel document that we need. Yeah, and then we also need to put File from Path in. Now I might run this one on manual, just for this case, in case we get some errors. Sheet name, so we want that's going to be called sheet. Sheet 1, which is pretty standard in Excel. Read as strings and show Excel will leave all that blank because they have default values, which is fine. If we hit run now, you can see that we have an error. Okay, we need to check that. So that sheet name is called summary, not sheet 1. Hit run again, and there's our data. So it's brought in that Excel data quite nicely. We need to manipulate some of this list information because we can't place a point in a model at this is not actual geometry, so we need to get rid of this data. So there's a node here called list.dropItems. Excuse me. List, and we want to get rid of the first item of that list. Hit run, and you can see now that center X, Y, and Z is gone, and we are left with this as our starting data. You can see now that list management is important when processing the data. You need to, as I said, read the Dynamo primer if you're new to this, just to understand what's going on and how to operate. So next we need to create some points in our in our Dynamo canvas. So we need to tell Dynamo that this is the X value, and there's the Y values, and these are the Z values. So what we're going to do is I'm going to split out these lists into 3 separate lists. I'm just doing copy and paste there with my shortcut keys, and we're going to just join these up here, and we are going to start with a 0 and a 1 and a 2. So what we're telling Dynamo to do is the index of this list is 0. We want to take out all of the zeros from this list, this list, this list into this node. Similarly, we're going to take out the 1s, and then we want to take out the 2s. I also need to play around a little bit with the levels here. So just change this here to layer 2, level 2. It means that it has to interrogate the information in this sublist as opposed to the main list. So if I hit run now, you can see that we have all of those values, 157, 123, 93, so on and so forth, and the other 2 have followed suit. So now to create the geometry inside of Dynamo, we're going to do point by coordinates. So we know that this is our X value, this is our Y value, and this is our Z value. If I click run, why isn't that? That's interesting. Okay. Number to number. Sorry. We need to convert the string to a number. So what happened was inside of Excel. The Excel data came out as strings, not as number values. If I hit run, there we go, that's changed that. So there's a little bit of troubleshooting that I've had to do on the fly. I apologize for that. So now you can see that we've got those points inside our Dynamo window, which represent the circles that we created in Civil3D to start with. So now we've got our points, we can start to use those points to place the block definitions. So over here we're going to create a block, and now there's a whole range of information that we need here. So source block, again going back to the previous script, we need to find the current document, and we are working in model space again. So that's the source block. The position of the block, they are the points, so we can connect these points up to there. The normal, we will just leave that as blank. Rotation, we're not interested, we'll keep that at 0. We can scale it if we want to, we'll leave that at 0 in this instance. We set the layer, and then we actually have to set the actual block definition that lives inside here. So just jumping back here quickly, our block name is called PowerPole. So we need to type that out in here. So code block PowerPole, and we need to also access the block reference. So to do that, we use document by our block by name. Okay, and our document is the current document. So what this is doing, it's finding the block reference in the project that's called PowerPole, and we're using that to say what block are we placing in the model. Layer, let's stick with, we'll put it on a layer called PowerPole just for ease of use here. Now if we just close this down, move this down a little bit, hit run, it's going to think for a second. Oh, it says it's complete, and it hasn't worked. Why has it not worked? Oh, I apologize, I've got it wrong. This is the block, and the source block is the block reference. There we go, sorry about that. So now you can see it's placed those block references at those locations based on the Excel spreadsheet that we've started with. So again, that's quite powerful. I couldn't do this in AutoCAD back in the day. You probably could do it with some Lisp routines, but yeah, you know, I never really learnt Lisp. So you can see now that using Dynamo, it's a really good tool to sit side by side with your normal processes in-house. I've shown some really basic stuff here today, but once you get into the Civil3D side of things, you can start to interact with the alignments and corridors, and you can also then start to access feature lines, baselines, or sub-assemblies and parameters that go with that. So this is when you can really start to leverage the power of what you have inside of your Civil3D models already. And then you can start to manipulate geometry and manipulate data inside of Dynamo to do some pretty creative stuff. So I'm going to wrap it up at that today. If you guys have any more questions, I can share these scripts with you if you like. Reach out to me. You can contact me on LinkedIn, search my name, Adam Walmsley, or you can email me at adam.walmsley@autodesk.com. Thanks for your time today. Can't wait to see what you guys come up with in Dynamo for Civil3D. I also forgot to mention the additional resources for learning. So the Dynamo Primer and the Dynamo Dictionary are two great places to go to. So the Primer, it explains everything there is to know about how Dynamo works and all the background information, understanding things like design script, what a code block is, some of the math and logic functions inside of Dynamo. And the Dynamo Dictionary is a really good tool as well. It explains to you what each of the out-of-the-box Dynamo nodes are. Two great resources, as well as the Dynamo BIM forum. It's a really active place where people do respond to questions, and it's a good place for help. It certainly helped me out in the past. Thanks, guys. Talk to you soon.